Everyone, myself Praveen. Today I'm going to talk about NFA to DFA. Let's see what is conversion of NFA to DFA. NFA means non-finite automata and DFA is deterministic finite automata. So let's see what is NFA. NFA means it occurs only more than one transactions, whereas in DFA it occurs only one transactions, that is Q0 to Q1 that is end state. So let's see what is DFA. For every string x, there is a unique path from initial state. So this is the initial states which associate with x, and x is accepted if and only if the path ends as final state. So let's take that example that q0 it starts from q0 that is started, and it ends with q1 that is called as final state, and it carries x is the value to from q1 q0 to q1. So let's see what is NFA. So NFA for any string x, there may exist none or more than one path from initial state and associated with x. So let's see what is an NFA for the x string for x. So this is conversion for NFA to DFA. Consider an NFA from Q. There has 5 tuples that it starts from Q that is states, and summation, transition, and finite f denotes final state, that is for x in stars. Summation star means symbol carries the symbols, and x q in q there exists a path that is it starts from x q. So define DFA from all the tuples from 5 tuples. It has 5 tuples, that is states q, and the symbols that is called as values, and transitions that is q0 q1 and q2 that is qn, and f final state. So where is, let's say what is q, it carries x in x symbols that, and transitions what I said in start for x in the star summation, start sigma, star denotes an a in sigma, and fx in L of m. So this is the final state for x of x in L of m. So this is called construction of m. So let's use construction of m means it consists of L of m means L of m means it consists of body of transactions. So let's see construction of m. Special case is m has no emu, that is epsilon emu. So epsilon carries s value symbols, and suppose x is known. How to get x of a for a in summation. So from x to xc, there exists path, and q to p for some q in x. So it carries the from q to p a, and some q in x, and p there exists in x absolutely, and a is the edge of to p, and it ends with union of q of a, that is it consists q in x. So construction of m. So this is construction of m of DFA to NFA. So f is equal to x of x in L of m, and this is the intersection. We had seen before that union, and this is the intersection uh, x of intersection of f. It's not to null. Now let's see small example for DFA. Construct DFA to accept 0, 0, 0 plus 1 and 0 plus 1 as to end. So this is the skeleton of starts from SP final state, and this is 0, 0, and S2P contains 0, and P2 final state contains 0, and it ends with 0 plus 1. So this is skeleton of DFA. So let's we construct one by one. So this is start state of S, and it carries 0 q to p, and p2 q is carries another 0, and from s it 0 from s to that's we had given that null exam we had taken that example, that's empty, that is null set, and it's again goes to the p, that is 1, and again it transitions as 0 plus 1. The ending should be 0 1 1 0. So the transition is satisfied. So 0 q2 to 0 1, this is the final state of q. So this is, let's a small example is designed to accept 0 plus 1 whole star. So it ends with 1 1. This is a small example, another to DFA. So it starts from S and 1 and S. Again it starts from P, SP, whole bar. So this is whole bar for 0 plus 1. So again it's S2 1, S2 0, it's end with 1 1. Okay, so S of 0 1 1 SP whole 0 plus 1, it contains SP values, and again SPQ values. This is the final state of 0 plus 1 whole star plus 1 1. So this is called another example for DFA. So it's almost it's end with 1 1 again. So this symbol, this arrow mark shows it. This is the final states, and again it transitions. It transition satisfies with 0 0 1 1. Which meaning we need that n should be 1 1. So it's satisfied. So from x to xa, and there exists a path q for a, sum in q, and there exists q in x. So h should be q to r contains a, and r to p contain epsilon. P for sum q in q, and r in transition of q of a. This is E closure R. And let's see construction of x. F of x is in LC of m, and x of x intersection of m, it's not equal to 0. So we are almost we constructed the DFA for the f of not equal to 0. So thank you.